Okay, so this is a small demo showcase of a clean architecture, well, distributed architecture project that I created like a week ago. I have added some small minor updates after that, but yeah, pretty much it was done like last week. And it consists of this, pretty much the architecture is based on this diagram. It has a load balancer done with YARP, and then the expenses clean architecture, which you can find as well in my repositories. It's like one of the previous clean architecture templates with some tweaks and improvements. Then I have RabbitMQ, and well, it's missing the Redis as well, but yeah, I'm using Redis for the cache, and RabbitMQ for the message broker, and yeah, mass transit to manage the events. It's event driven architecture, right? So I'm using mass transit, protocol buffers to define the shared messages actually between microservices, to force myself to deal with the context propagation problem in distributed architectures, which was one of the main problems with working with OpenTelemetry, which is the main goal of this project, right? Like to learn OpenTelemetry and OpenSearch. That's why I added this distributed architecture. Like if you go to notifications microservice, it's basically a .NET new web API with all the weather forecast bloated removed, like all the boilerplate removed, right? And with the necessary stuff added. So yeah, basically this is the reason why I added notifications was to force the distributed or the context propagation stuff. And then yeah, just a regular database. It's Microsoft SQL Server, right? Like just a regular database, relational database. And then all the OpenTelemetry stack stuff, well, OpenSearch stack, which is basically the open collector, right? Where all the signals, like the three main signals, the login metrics and traces are going to be redirected, or yeah, like sent. And then open collector, then the data prepper, which is necessary for the OpenSearch to understand that those signals, right? It's like a middleware, so to say. And then from there, we are going to consume that information with the OpenSearch dashboard, right? I have some screenshot right here from the project after doing some requests. As you can see, we have the YARP gateway, right? Like this one. The whole trace would be consists on the gateway, the expenses, and then from the expenses, there's sent an integration event is sent to the notifications microservice, and yeah, as you can see, the context gets propagated in the same trace, and the correlation trace ID it's maintained, right? And the spans keep the tree of span ID and the parent of all the children, right? So yeah, it's working perfectly fine. And also the logs are correlated to the trace. This is just one of the, yeah, and if right here, if you see in the dashboard, you have view associated logs, and that takes you to this window right here, to this screen. And if you do this query, it will show you the log associated with the trace. So that way you can also take the actual information, right? You can log meaningful data, like the values of the elements themselves, and then you would see those values apart from the traces information, right? And the metrics also are being sent, but for some reason I haven't been able to make them work. So yeah, I'm working on it yet. And yeah, if we go more into detail, I'm gonna show the hotels, the protos, sorry. So the protos, the architecture, as you can see, it's just a protos directory where the protos are located. following the convention and the entity, and then the versioning and the actual proto with the syntax, with the proper syntax of Proto 3, right? Like the package definition, and this because it's a .NET project, right? And then the enum in this case. I'm using the enum because, yeah, the notifications are generic. So I decided to create an enum to define if they are related to categories or with auto expenses or whatever, right? And then the unspecified, which is necessary, right? If you remove it, you have a warning. So it's part of the definition of the Protos enums, right? And then in the other directory, you have notification version 1 and notification Protos the same way. In this case, we also import the enums, right? And yeah, we just define a notification event message, which is basically what we are going to use in the both microservices, in the notification one and in the expenses one, to share information, right? To do actually this information sharing. We are not using the protocol buffers to do the RPC synchronous communication, but just to create some language agnostic DTO or message to be shared between microservices, right? I mean, I could have done as well, like notification service, right? And inside here, just define a service, notification service, and here the RPC request, whatever request, and then returns, I think it is, and empty from Google or whatever, right? But we are not doing that right now. I mean, this was just to deal with Protos, and the main idea was to make them work, right? Also to learn about Protos, and yeah, I mean, with this is just enough. Was enough for me. I mean, yeah. And then to make them work in .NET, it's pretty easy. If we go to the application CSProc, this is like this is a clean architecture, right? We are inside a source, services, expenses, application layer, and if we go to the assembly, right, to the CSProc, the only thing that we need to do is add gRPC tools, this one right here, and the Google Protobuf, and then we just need to add this line right here, like which are pointing to the actual Protobuf location. Since we are not creating any service, we don't need to define any service, right? Not client or server. And the proto root, right? Which is, this is important for the imports, because they are based on the proto root, right? Which would be basically this one, right? Like the actual root. Yeah, and with this, every time we do .NET build, right? Like every time we run .NET build expenses, this will generate the actual protos, right? The protocol buffers, and so we can consume them. And I'm using the protocol buffers just in the post category command in this case. Yeah, I mean, this is just a regular feature, right? Like the a post command, so a create category command, so to say. And this just checks the validator, post the category to post, right? Well, it's mapped, and then it gets posted to the context, saved with the int work pattern, persist, so to say, and then it gets well, yeah, then I remove all the keys from the Redis cache related to the category, and then I just have one of the domain event, right, which is written in C#, the category posted event, which is right here. I have defined the event, the domain event, and then the consumer in the same place, right, to be like grouped. But then I have this this would be the integration event that I was talking before about, which was this is the protocol buffer, right? If we go to the definition, if we use language server and go to definition, it will take us to the actual compile code. Yeah. So yeah, basically it's the ProtoC compiler compiles every time you run the application with, if you are using Visual Studio with F5, or every time you do the .NET build, right? And yeah, this is basically the same entity as here. If we go to Protos notification, yeah, this is the entity ID, the entity type, which comes from the enum, this one, entity type, the name right here, 3, and description, right? You need to define these numbers, 1, 2, 3. This is by convention for Protos, like every attribute has to have a name related, right? For serialization. Okay. So this is right here, and then we have in the notifications microservice, which is basically a .NET new web API, as I said before, with everything removed. We could have removed abstractions and this as well, but well, I had the idea to use them after this demo. But yeah, for now, this and this are useless basically, and the only thing important is the program configuration, where we define, well, in the notification as well. This is defined in both sides, right? Like the mass transit configuration. Right here we have, well, sorry, expenses one, yeah. But since this is a clean architecture, I have the extension, so this same program thing related to as mass transit, it's located in the infrastructure dependencies right here. And right here we are defining all the consumers, the domain events, and the domain events, right? Like this one, this one, this one. But right here we only are adding the integration consumer, which is located here. And in here we define the consumer related to the actual integration event, which is this one. And if we go to the definition, it's the compile code as well, right? Yeah, and basically what we are doing in all the cases, it's just logging stuff. We are not sending anywhere or whatever. And in this integration event, we are doing the same. And after that, yeah, that's pretty much it related to OpenTelemetry. I mean, to the protobufs, like to the protocol buffers. That's what I use them for. And then related to OpenTelemetry, if we go to the Docker Compose collector, yeah, we need to define a series of services in order to OpenSearch to work for the whole stack based on the standard, right? Open hotel collector. Hotel means basically it stands for OpenTelemetry. Sorry, yeah, for OpenTelemetry. And this is basically like the catalyzer, right? Like, so all the signals, the logs, traces, and metrics are sent to this service right here, to the collector. And we have a configuration, this one, where we defined the protocols in which the information is sent. So in this case, we are creating two endpoints, right? One with to the 4317 through gRPC protocol, and through 4318 to the HTTP protocol, right? And the HTTP is right now it's useless because we are using all the time gRPC only, right? But yeah, we could have used this as well if necessary. So I am basically the important part for this for OpenTelemetry. We need to set we need to add the OpenTelemetry in the services. And well, there are some packages already built in, already available, which are the instrumentations, and they add for you all the trace related stuff automatically. So basically, every time we do a request, we create a trace which has a trace ID, which is unique. And through all the interactions in that request, it's every time it interacts with some meaningful part of the application, it creates an span automatically via this instrumentation. So if, for example, in runtime, well, these are for metrics, but runtime adds all the instrumentation related to metrics, like like the time for each request, like the RAM consumption and all those kind of metrics, and the HTTP client the same. And then for the traces, we have the ASP.NET Core instrumentation, which adds the spans to the request, to each request, the HTTP if we have used HTTP, with which we are not using, I think, but well, whatever. And well, this is for the notification, but if we go to the expenses one, which is the clean architecture one, we will have as well the Redis one. Yeah, right here. This has entity framework one, the HTTP which we are not using, the Redis one to the cache, right? It also auto adds spans related to the Redis and keeps the track of the tree as we have seen here, right? Then this one it's important because this is related to the mass transit, and this is actually what respects the context propagation. Well, it takes care of the context propagation. Every time mass transit needs to send an event, it injects the information related to the previous span and the correlation trace ID. So when it gets consumed after being sent to the RabbitMQ, when it gets consumed, the service that consumes knows about the context, right? So this basically it's related to mass transit. If you go to definition, you will see that this constant right here, it's related to mass transit, right? This one. And then yeah, we define the exporter, which is the same, right? It's the service which is defined here, right? And yeah, the configuration of the collector, which are it has like three parts: the receiver, which is the gRPC, well, and also this instrumentation. If we go to the CSprog application, CSprog, no, not application, infrastructure CSprog are these ones, basically, like this one: OpenTelemetry exporter, the instrumentation of Sublingual Core, entity framework core, instrumentation HTTP. Some of them are I don't remember the tag, like they are not stable. They are, you need to define that they are well, yeah, I mean, like they are like nightly version, or I don't remember the name that they use, but yeah, it's like you need to define that, or indicate that they are nightlies. Maybe I have, yeah, pre-release. You need to define the tag, as you can see here, the pre-release tag, right? Oops, I didn't want to do that, I guess. Well, yeah, actually, probably it's the same, but okay. Okay, so yeah, this is basically what it has, and after that, after being sent to the collector, you have after that it's the prepper, right? The data prepper, and the pipelines. The important part about the data prepper, basically, it's these two configurations which are located in the root, right? I have them right here, and we need to define a volume so we can share them with the actual container, because everything is dockerized, right, in this demo. So we need to add them to these specific directories, share data prepper pipelines, and this is the config. And yeah, the config of the prepper, it's basically we remove everything SSL related, because otherwise we would have needed to add all the certifications, the certs and the user password and stuff. And yeah, yes, because we only focused on making it work, right? We remove everything SSL related here as well. And right here we are using the version 2. Previously you needed to deal with the 3 signals separately, but right now like data prepper since version 2.7 I think allows you to use the unified port, or yeah, unified ingest port. So you can redirect the three data signals to the same port in this case. And that's what we are doing, right? Like we expect the source of this, we define this way, the OpenTelemetry, well, I mean, this could be whatever name. We define the source as OTLP, like OpenTelemetry Protocol. And if we go to the collector, we are sending, well, before this is the receivers, the processor, which is optional, like this just batches the signal, and the exporters, they book just because I was debugging before. But the real important one is this one, right? Like the OTLP data prepper, it's just a single endpoint, so it's a unified. The 0 was for logs, the 1 was for metrics, and the 3 was for traces, or the other way around. But and the 3, it's the default for the combined like for unified endpoint. And this what we are using that with the ODLP data prepper. And that's, if you check right here, we define the pipelines for the collector, and yeah, the receiver is the ODLP, so this one, and then the batch, and then the exporter, it's the only endpoint, the single endpoint that we have defined for the 3 signals. And here we receive them. Also, if we need to use data or the reason why we are using data prepper is to send information to the OpenSearch, we need to add this one right here, so it will add extra metadata information, whatever it's mentioned in the official documentation. And well, this unified signal gets disclosed with these 3 calls, right? With these 3 functions: get event type equals log metrical trace. This separates the 3 signals into 3 different sinks. Since logs doesn't have a built-in plugin, it's sent right away, like they do the OpenSearch with this index, right? With this format right here. This index actually is because OpenSearch dashboard, when you click on the related log, for some reason it adds this prefix. So yeah, just add it right here. Probably you can modify it in the OpenSearch dashboard, but just in case, for that reason I'm adding this SS4O, right? Then pipelines. For the pipelines, there's an actual plugin, so we are using this down here, right? So we define the pipeline, we name the total metrics, which is this one, and the root, it's the metric. So the one when we separate the signals, we redirect this one to the total metrics, right? And these metrics, the processor, it's called this one, it's called AutoMetrics. This is the plugin that processes the OpenMetrics, and then are sent to the OpenSearch service, or backend. Are funded traces the same. The processor is AutoTrace row, and then these are sent using the index type trace analytics row, and then this is sent to the OpenSearch, which is here. There's nothing important in the configuration, right? The volume we are defining here is just the same way we will define a data in any database, just to keep track, to make it persistent in between, like Docker Compose up and down, right? And all the stuff that we need to remove security related stuff, like adding user password, SSL and stuff, right? Like by default it generates some demo configuration, and we don't want that either. So yeah, but nothing related to, like built-in config or whatever, right? This is just to remove security. And then the dashboard, the same, just remove security and yeah, the port definition. Well, and this well, actually the host, you define the host from the like the origin, right, of the information, which is the OpenSearch API, right, which is in the 9200. And okay, so this is basically the whole project, and this is running. This is running. If I go again, well, I'm gonna remove what I added because I don't want to mess anything. Okay, so this is already running. I'm using lazy docker for that, but yeah, you could use whatever tool you like to use. And also I'm gonna open Kulala, which is like a, like Insomnia or Postman, to do my requests. And since this is running, right, like we could go to Swagger, I think. Yeah, so this is already running, right? So if we do a request, since everything is securized, we need to actually, yeah, if I do a get all right away, it's going to return me a 401 probably. Yeah, this one. So first we need to get the token, right, the access token, and see that right here I'm using this dynamic way of accessing the token, right? In Kulala you can do it like this, probably in Postman or Insomnia you can do it too, right? So this is basically it's requesting, and I'm also actually requesting the, well, using the reverse proxy, right? Like I'm using YARP. So this 8100 it points to the Docker Compose, the gateway, which is right here. Yeah, 8100, which is the HTTPS port, and then internally it redirects stuff with HTTP, right? If you go to app settings, we have the reverse proxies defined right here from the cluster expenses cluster, right? If we go, which is it's defined, yeah, right here, expenses cluster, right? And yeah, basically are all the routes that get redirected right here. And you define, yeah, this one, you define the destination, expension destination. Since notifications, it's not accessed other than consuming events, you don't need to define any route. In fact, there's no route in notifications, so we only define the expenses in this case, right? If we had more here, we would need to define notification destination and add that address, right? But there's no need right now. So yeah, basically it redirects to the expenses, which is 8001. Yeah, so yeah, so the request is sent to the gateway, and the gateway redirects to the expenses, and the token it's obtained from the login. This actually points to the name using hashtag to this previous call, and then we access the response body dollar, and then access token, which is the actual value right here, right? So if we do this request, it's going to return the actual items, right? Like the development categories, groceries, subscription, blah blah blah, which is basically located in the Beaver database, right? If we do a request, we have them right here, right? And this should be logged in our OpenTelemetry stack. If we go to the OpenTelemetry traces, we order by today and data prepare and only the root ones. And so we did a cut 1042, yeah, this one. We first did the identity and then the category call, right? So if we go to the identity, we're going to see the request, right? The expenses, this is the entity framework, so the access to the database, and this is the yeah, both entity framework. The framework call and the claims. Okay, vale. And then if we go to the actual category, get all categories, right? It goes, yeah, it marks the time spent by different microservices, and you have the information of the Redis, which first access Redis, since there's the first call, it's not going to exist, so it access database. Yeah, and then it saves in the cache. Well, I mean, that's whatever, and then in the cache, it should add. Yeah, it cached in the stack, right? So the next time we do the same call, it should be cached. If we go back, well, it takes some seconds to actually perform. Yeah, this one. And if we go right here, we can see that the duration was way less because it's cached from before. And there's only one call, which is the first one, which is the stack trace. Yeah, so this is useful for that to check that everything is working fine, right, and properly. And also, we don't have logs, meaningful logs right here, but I'm going to do the call that when we actually use the integration event, which, for example, I mean, there's a test description, and we are going to call test, right? So we do that. It actually created that test. It created, right? And so if we go to the containers, we are going to see that the expenses got this domain event with the structure login, the description, blah, 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 whatever. And then this should have been sent via mass transit to the RabbitMQ message broker to the notification, and this has the consumer. And yeah, it got like logged like the category test and the description, right? Which basically it's what we have in the consumer. Basically, it's like this, right? The entity type, name, description. From the protobuf, right? Like this was shared with the compiled code by proto-C from the protos, from the defined protos. And if we go to the OpenSearch, we refresh. Well, it got stuck for some reason. Yeah, these categories means, well, this is the creation one, right? So we go right here. We have, yeah, we have the whole like context propagation and the request as a whole, right? Like the gateway, it went to the expenses, and then through the integration event went to the notification. We have all the trace here, and then we also, in this case, since we have two login events, we should be able to trace them. If we go to associated logs and then we run this query, it will recover the associated logs. And if we go to the one with the actual data, which I don't see what it is, this one maybe, yeah, we can see, you know, the test. so we can log the actual information that could be useful in not only in our containers or in our debugging tool, but also in the trace we have the related related logs, so we can see the actual information that we were dealing with, right? So that's why it's important and it's useful to use these observability tools. Yeah, and that's basically it. Well, metrics are not working for now. Well, I mean, I can access OpenTelemetry and the different telemetry stuff, but I'm not seeing anything, right? Like, I don't know why is that, but yeah, whatever. I mean, there's some issues opened in the official repository, so maybe it's because of that. But yeah, I mean, I have to fix that. But yeah, overall, this is the project, and this was a small showcase and demo of what I did to learn about protobuf and OpenTelemetry. And yeah, that's pretty much it.